We're going to look at how to graph all 6 of our trig functions. We're going to look at sines and cosines first, and then secants, cosecants, tangents, and cotangents next class. But you'll all be here for that. So let's think about sine first. We know that we can always just plug in values for x and get a graph that way. We know that the sine of 0 is 0, so we can graph that first. Oh yeah, and on my graph I've only gone from -1 to 1 because we know the range of sine and cosine are both from -1 to 1. We also know the period of sine and cosine is from 0 to 2 pi. So after 2 pi, they're just going to keep repeating themselves. So we don't need to worry about what happens after that. All right. The next angle that we know the sine of is pi over 6. We know the sine of pi over 6 is a half. So pi over 6, a half. We can graph a point there. We know the sine of pi over 4 is root 2 over 2. If you punch that in your calculator, it'll tell you it's about 0.7. which is here or so. We also know that the sine of pi over 3 is root 3 over 2, which is 0.866. Put that right about there. And we know that the sine of pi over 2 is 1. We can put a point there. We also know that sine is positive in the second quadrant. So from 0 to pi over 2 is the first quadrant. From pi over 2 to pi is the second quadrant. So we can mirror each of these points over into the second quadrant and get what is going on with our sine function over here. And again at pi we have a 0. And then for the second half, sine is negative, but it still makes that same sort of shape. When we get to 3 pi over 2, it's at -1. When we get to 2 pi, it's at 0. So one period of sine, pretend that goes through all the points, looks more or less like that. Okay. Cosine looks very similar, though it doesn't quite start at the same spot. We know the cosine of 0 is 1. The cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. The cosine of 2 pi is 1 again. So one period of cosine looks like this. Now, if we kept going and kept plotting more angles, we'd find that cosine just keeps going, following that same pattern, and sine also just keeps going, following that same pattern. But we're not going to bother doing that because we only really need to worry about one period. Now, I'm never going to ask you to graph just sine or just cosine, but we need to know what the basic graph looks like before we can graph more complex functions involving sine and cosine. Now, so let's take note of a couple things here. Sine follows a pattern, and its period is 2 pi. Every fourth of a period, it hits one of these important points, a 0, max, min, or a 0 or max or min. And cosine does the same thing. Sine starts out at a 0, goes up to a max, back down to a 0, then to a min, and then back to a 0. That's what one period of sine looks like. Cosine starts at a max, then goes down to a 0, then to a min, then another 0, then another max. And each of these points occurs, this is at the start of a period, this is a fourth of the way through a period, this is a half the way through a period, this is 3/4 of the way through a period, and this is at the end of a period. So we're going to use that pattern to graph more complicated sine and cosine functions. We're going to look first at what happens when we multiply our trig function by something, or we multiply what's inside the trig function by something. So we know when we multiply our function by a value, we know that that causes a vertical stretch from things we've done with other types of functions. With trig functions, they're often related to waves, so that vertical stretch has a special name. It's called the amplitude of the function. So whatever's out there is how far up our function will go. So the basic sine and cosine functions go up to 1 and down to -1. So if our amplitude is, say, 5, then the function will go up to 5 and down to -5. What's inside there affects the period of our function. So normally our period is 2 pi. Well, in order to take the sine of 2 pi, if we want to take the sine of 2 pi, that's wherever 2 pi is equal to bx. So at x equals 2 pi over b, we'll be taking the sine of 2 pi, and that 2 pi over b then is the period of our transformed function. We can use that information to graph transformed functions. And I use sine as an example, but the same thing applies to cosine. Its amplitude changes and its period changes in the same way. So let's say we have f of x equals 3 sine 2x. Right. The 3 is the amplitude of our function, which means we're going to go up to 3 and down to negative 3. The 2 affects the period. Our period is 2 pi over 2, which is just pi. So one full period is just going to be pi. From looking at our parent function, we discovered that critical things happen at every fourth of a period. So we need to split our period into fourths. Pi over 2, pi over 4, and 3 pi over 4. And from there we could plug in a bunch of values for x, but it's simpler if we just follow the pattern that our basic sine function had. We knew we started at 0, and then a fourth of the way through a period we're at a max. Then we go back to a 0, and 3/4 of the way through the period we're at a min, and then back up to a 0. And so the function looks like that. Okay. Cosine functions transform the same way. Let's say we had 2 cosine of 1/2 x. Well, that 2 is our amplitude, so we need to go up to 2 and down to negative 2. The 1/2 affects the period. Our period is 2 pi over b, which is a half, so our period, in this case, is 4 pi. So on our graph, we need to go out to 4 pi. Then we split our period into fourths, 2 pi, pi, 3 pi, and then we can just plug stuff in following our pattern for cosine. Cosine goes max, 0, min, 0, max. So we start off at a max, 0, min, 0, max. And that's what our cosine function looks like.